A little while ago, I was asked to give my thoughts on this, the Annin Robotics DIY open source robot project. So this is a project which has been going on for a few years now. This is an open source 6-axis industrial robot essentially, but a very DIY entry-level version. So it's actually really well done. It's pretty clear that Chris Annin's got a good background in industrial robots, and that really sort of comes across in this thing. To give some idea of background for me, I've spent 20 plus years dealing with industrial robots from ABB, KUKA, Fanuc, Motorman, Kawasaki, Universal Robots, and a few others. And I was working as a robotics consultant for the automotive industry, for investment firms, and I've worked with robot startups, including a few in the UK, in Switzerland and in the States, before I got into 3D printing and lubrication. Anyway, so yeah, my general thoughts on this is that it's very, very good. Generally, the structure's pretty good. The way of controlling it seems pretty capable. So let's have a look at the positives. Programming, it's really good. The fact it's open source, the fact it's good value, and we'll have a look at that in a minute. The upgrade potential is quite good. The fact it's educational, works for proof of concepts, it's well established, so it's a project that's been going on for a little while, and probably most importantly, it's better than the competition. So I've dealt with a couple of startups at a similar sort of level to this, and this is far lower cost and is better supported. But we can have a look at the negatives and why you wouldn't really want to use it beyond educational proof of concept uses. So you wouldn't really want to use it in a real world application where you're actually making parts necessarily. And that's because of the parts that you're dealing with. So you've got stepper motors, which aren't nearly as good as a servo motor. The rigidity is not really there, and the thing is, there's two levels for this. So there's a 3D printed version, or there's a metal plate version, but either way, an industrial equivalent is going to be much, much better. Precision wise, the industrial is going to be much, much better. The gearbox backlash is not great on these. Speed is going to be relatively low, which in turn is quite good from a safety perspective, because the thing's never going to be moving fast enough to really hurt anyone very much. But it hasn't got the sort of dual channel safety that you'd want in an industrial spec machine for CE marking and sort of installation safety really. So the other major issue is durability. So the durability of this is reasonable, it's pretty good, but the cables especially, I suspect, are going to cause problems in the longer term. Price wise, this project is quite interesting. It sort of starts at 1,000 to 2,000, and if you compare that to a used robot, it's not that much cheaper than a reasonable used robot arm. It'd be harder to find one around 3K. You're probably looking at one which is quite old, but you can find them out there. A little bit of a gamble if you don't know what you're doing. A bit more expensive if you want to get one off a trusted trader with some sort of warranty. The new Chinese machines are the real sort of eye-opener. They go right down in price now, so that you can get a completely new industrial spec machine for under $5,000, which will really do you a job in a way that this just simply isn't going to. And then you could go for the new ABB, KUKA, Universal, whatever else, but they're going to be sort of 20 grand plus. So that gives you an idea of the price. Now, the way that the pricing works on the Annin is really quite interesting, because what they have done is that they have split the robot up into sort of sections. So if you look in the kits section, we basically have a kit of sort of wires and bits and bobs, and that's like the full kit, which is like $1,200, but you need the motors on top of that. You can 3D print these big parts, these big metal parts, or you can then upgrade, or you can buy this aluminium set, which will give you more stiffness, but again, it's not going to be as stiff as a sort of cast aluminium part or something like that, which you're going to have on an industrial machine. So you've got hardware kits here, and again, things like lubrication and the durability of cables and stuff is the sort of thing which is probably going to cause you issues. Now, the way it works with the servos is you basically buy this kit from here, and then you buy a complete package of stepper motors and stepper motor drivers from Stepper Online, so they've got a kind of partnership with them. And this allows them to keep the price down, because you can see, like, you've got £600 there, which is about $800. So you're looking at, again, $2,000 all in for the complete machine. And that's going to give you, you know, all the motors you're going to need, all the sort of basic setups, and obviously getting it going is not going to be that bad, because you've got a lot of documentation, a lot of how-to videos and stuff. Got a decent forum that seems lively, so all that stuff is really positive. But if we have a quick look at these motors, so if we look at the spec of one of them, we can kind of see where things are falling down. Now, these are closed loop motors. The gearboxes from Stepper Online are going to be pretty decent quality, and they're going to, well, I mean, it says they're going to last a little while. Life 6,000 hours. Now, that is some way below the 30,000 hours that you can expect from a sort of cycloidal type gearbox. This is a little modeler one, but you can see, like, they're a bit more intricate and require decent materials technology. They're a bit more advanced than a planetary, and you're not going to have the backlash. The other option, strainwave gearboxes, again, they're much more expensive, usually about at least a few $100s an axis, up to $1,000 an axis, but that's going to give you much better backlash, and indeed a much better gear ratio, much higher, the opportunity for higher gear ratios. So these gearboxes are planetary, and they have a backlash at no load of less than or equal to 15 arc minutes, which is pretty good, but you really want that down in single figures and really under 5 for a robot arm. And by the time you've stuck that up through the gearing, that might not be very good. Likewise, the stepper motors just haven't got the power density. They haven't got the power that you really want for the speed and all the rest of it of an industrial robot machine. So yeah, there are weaknesses here. Overall, I would say it's very good if you just understand the limitations of the machine. So if you understand it's a DIY project, it's, you know, entry level, it's going to teach you an awful lot. If you're a hobbyist or something like that, it's, you know, quite an interesting thing. Yes, you could probably automate some very simple low speed processes with it. No, you're not going to want to stick a MIG torch on the end of it and try and weld anything up. It's not anywhere near that sort of level, and it's not going to have the level of interface or the level of IO and all the rest of it that you're really going to want for an industrial machine. So yeah, that is the Annin Robotics project. Really good value, really interesting bit of kit. If it's interesting, then I would suspect that it's, you know, it's a very good, as I say, it's much better than some of the other stepper driven robots that I've seen out there, but they too are not really on the industrial robot level. But if you're looking for something like this, then this is, yeah, not a bad option in my opinion.